the arc length of a curve and surface area. Let's given the curve y equal f of x in between point A and B, and we want to calculate the length of the arc. So in order to estimate the length of the arc, we divide the arc into small sections so that we can estimate the length of this arc. Now, when we do that, each of the segment here, the length of this arc from f of x naught to f of x1, if x naught and x1 is sufficiently small, then the length of f of x naught to f of x1 is estimated to be the hypotenuse of the small triangle, with the length to be x1 minus x naught and the height to be f of x1 minus f of x naught, right? So this length here. So we can calculate this hypotenuse based on that formula. So we estimate the length f of x naught to f of x1 is about the hypotenuse, so the square root of x1 minus x naught square plus f of x1 minus f of x naught square. Okay, so that's the idea. Now we will add up all the length of that small hypotenuse to get the length of the entire curve. So that's the idea. Now let's put it in terms of calculus. So let's say we take a look at the length between f of xi minus 1 and f of xi. Then the distance, then the length of this triangle that we have earlier is expressed as delta x, the difference in x. And the distance in y is being expressed as delta y. So then this length, this hypotenuse here, is to be expressed as square root of delta x squared plus delta I squared. Okay, so then the length is square root of delta x squared plus delta I squared. So let's go ahead and I will factor delta x squared out of that equation. Then now I get 1 plus delta y squared divided by delta x squared. This whole thing under the square root. So then again, I have delta x multiplied with square root of 1 plus delta y divided by delta x squared. Okay. So by the mean value theorem, there is a point xi in between that interval of xi and xi minus 1, such that f prime of xi star is the delta y of I divided by delta x. So this is the definition of the derivative. Okay, so then now we're looking at that. Well, then this meant, well, the arc length then approximate to be the sum when I equal 1 to n of this many segment. So by Riemann sum, if we let take the limit at n approaches infinity, then we'll have the arc length formula as the integral measure from a to b of 1 plus f prime of x squared dx. Right? So let's take a look at this first example. Let f of x equal to 4 root 2 over 3, of x to the 3 over 2 minus 1. And we want to calculate the arc length of the graph f of x over the interval 0, 1. So first thing first, we need to find the derivative of f of x. So let's take the derivative of the f of x. F prime of x is equal to 4 root 2 over 3 multiply with 3 over 2 x to the 1/2. Derivative of 1 equals 0. So then here we have 4 root 2. So this is 2 root 2 x to the 1/2. Okay. So let's plug this into the formula. Well, then the length of this arc from 0 to 1 is equal to square root of 1 plus 2 square root 2 x to the 1/2 square dx. Let's clean this up. That's 0 to 1 square root of 1 plus 8x dx. We will evaluate this integral by u substitution. So we will let u equal 1 plus 8x. So then du is equal to 8 dx. This means 1/8 du is equal to dx. Since we do a u substitution, we need to change the upper limit and lower limit. When x equals 1, u is equal to 9. When x equal to 0, u equal to 1. So now we have the new integral evaluate from 1 to 9, that 1/8 u to the 1/2 du. So then this length is equal to, so 1/2 plus 1, that is 3 over 2, so 2/3 times 1/8 u to the 3 over 2. Evaluate from 1 to 9. So simplify this, we have 1/12 times 3 to the 3rd minus 3. And this is 1/12 times 27 minus 3. This is 1/12 times 24. Excuse me. So here we have, when we evaluate with from 1 to 9, when u equal 9, we have 3 to the 3rd. But when u equal 1, this is 1. So 27 minus 1. And we have 26 over 12. Simplify this a little bit. This is 13 over 6. So this length is about 2.17. Let g of y equal 3y squared. And we want to calculate this arc length of the graph of g of y over the interval 1, 2. So first, we calculate the g prime of y. Well, g prime of y equal 9y. G prime of y squared is equal 81y squared. So when we calculate this integral, the arc length is the integral from 1 to 2 the square root of 1 plus 81 y squared dy. Now we don't know how to calculate this integral, so we'll go ahead and we'll use computer software to estimate the length of this segment, and we will estimate this integral. So what I've used is a Google Sheet with Calculus app add-on with an extension. So first of all, I'll say here I have my y, and here my function g of y, and I'll get there in a little bit, and here is the integral. And that's where I put all my stuff. Okay, so when I want to calculate this integral from 1 to 2 of this square root of 1 plus 81 y squared, well, I will define y to be my cell C2. And since we take y squared, we use the power function. And you get a 1. That is to be expected. Now, recall our function is square root of 1 plus 81y squared, and we evaluate this integral from 1 to 2. So when y equal to 1, the square root started now at square root of 82. So now we will use the function quad to estimate the integral. We start out with our function, our x value, or our variable of integration, and we want to calculate from 1 to 2. So the estimate length of that segment is 13.54. Okay. In the next example, let's find the length of the curve y equal x over 2 to the exponent 2/3 from x equals 0 to x equals 2. So first of all, we take the derivative. Y prime is equal to 2/3 times x over 2 to the exponent negative 1/3 times 1/2. This simplified to be 1/3 times 2 over x to the 1/3. Note that in order to calculate in this integral, the function have to be continuous, right? But here, as you can see, when x equal to 0, y prime is undefined. So what we do is let's rewrite the equation in terms of x instead. Okay, so let's rewrite this in terms of x. This means if we start with the function y equal x over 2 to the 2/3, this telling me x is equal to y to the 3/2. So if I take the derivative with respect to y, x prime is equal to 3 times y to the 1/2. Then here we resolve the situation where we have a undefined. Now I can calculate the length of this integral. Note that because I change the value, because I change from evaluate the integral from x equals 0 to y to x equals 2 to the thing in terms of y, I have to change the value I have to have the value of x and y in accordance to each other. So when x equal to 0, y is equal to 0. And when x equal to, y equal to 1. So my integral now evaluate from 0 to 1. This is square root of 1 plus 9y dy. I can take this integral with respect to y by doing u substitution. So let u equal 1 plus 9y, du equal 9 dy, 19 du equal dy. And I have to change my upper and lower limit. When y equal 1, u equal 10. When y equal 0, u equal 1. So the integral is evaluated from 1 to 10, 19 times square root of u du, and this equal to 2.27.